Ultrasonics is advanced technology providing a simple solution to a complex problem. The medical technology of echography is exactly the same as the technology that we're using here. We've taken this technology from the medical world. The medical technicians use this for fetal development in pregnant women, and we're using exactly the same technology, and the benefits that we have now is that we have an image that's much easier to identify than previously with industrial ultrasonic images. The application on gold and in the airline industry is identical from a technical point of view. There's a requirement for the highest levels of security and integrity, and we're applying those to gold inspection. The defects that you tend to get on rail tracks tend to be caused by the rail wheels hitting the track, and you get a defect that occurs at the surface, and it grows from the surface and it gets bigger, which is why it needs to be checked regularly, and eventually it will go all the way through and cause a catastrophic failure. What we're looking for in gold bars are defects that are there permanently. They aren't going to grow, but they could affect the integrity of the gold bar. Using the ultrasonic technology and the Phasor XS from General Electric, we can look inside the material inch by inch, millimetre by millimetre. The first thing we have to do is apply a gel. The purpose of the gel is to exclude the air from between the probe and the gold bar. We then put the probe onto the surface and look at the image that we get on the screen of the phaser, which basically shows us the top of the material, the bottom of the material, and this is where we are non-destructively looking inside the material. So we've got a cross-sectional view, and as we move the probe, we're effectively non-destructively looking inside the gold bar wherever we position the probe, and if we had an air gap, a void, another material inserted in there, the image on the screen would clearly display that. We're now going to test a brass sample with the Phasor XS. First thing we have to do is select a different material for the instrument which has changed the acoustic velocity. We then need to put the couplant on in exactly the same way that we did with the gold bar. Now we put the probe on and we have our section, and on this image we can clearly see that we now have a defect showing. Top of the material, back of the material. That's the indication of a defect, and that's how a defect would look in a gold bar. We've now moved off the defect. We carry on scanning across the surface, and now we've got a much larger defect showing, so that's a signal from the larger defect, and in fact that type of signal is what we would expect to see from an insert as opposed to a void. That would be the signal from a void, a small isolated indication. That would be the indication we would get from an insert. Ultrasound as a method for inspecting gold bars should give you a very high level of confidence that you would detect any discontinuities or contamination in the gold bar.